Hello students, I am Tara Sawant from Empower Education, and today we are going to start with an interesting chapter in physics, light, reflection and refraction. The chapter is divided into two parts, reflection and refraction. The points that we are going to cover pertaining to reflection are reflection of light, images formed by spherical mirrors, mirror formula and magnification. And the points pertaining to refraction are refraction of light through a rectangular glass slab, refraction by spherical lenses, image formation by spherical lenses, lens formula and magnification and power of a lens. So we are going to start with reflection. Now students, have you wondered why we can see things very clearly? Or what is the reasons that things are visible to us during the day and not during the night? Let us consider, suppose if it is a dark room and you're inside a dark room and I tell you to locate an object inside a dark room. Are you able to locate objects inside a dark room? Is it easy for you or is it difficult for you? Right, it is difficult for you, right? So, we can see objects clearly during the day because of sunlight. Now, when sunlight falls on an object, the object reflects the light that falls on it. Now, this reflected light is then perceived by our eyes and we can see the object very clearly. Now, this is because of reflection of light. Now, see students, you can see in this diagram, I have shown you all reflection on a smooth surface and reflection on a rough surface. Now, if you have a look clearly at the reflection on a rough surface, you see the reflected rays here are not parallel to each other. You see they are kind of, not in line with each other. This is an example of diffuse reflection. But if you have a look at the next diagram, that is the reflection on a smooth surface, you see that the reflected rays are parallel to each other. So you see this is an example of regular refraction. If we consider an example of reflection, we have plane mirrors in our home. So plane mirror is a reflecting surface. Now, to understand this phenomenon of reflection, we have certain rules of reflection, or you can say certain laws of reflection. Now, reflection can take place only when these laws are satisfied. Now, you see in this figure, I have a plane surface and to that is a perpendicular normal. Alright. Now, when rays are incident on the smooth surface, when it strikes the smooth surface, you see it is getting reflected back. Now, when it is getting reflected back, the angle of incidence here should be equal to the angle of reflection, which means if I denote angle of incidence by I and angle of reflection by R, my I should be equal to the R. For example, if you have the angle of incidence as 30, then the angle of reflection should also be equal to 30. This is the first law of reflection. Now let's talk about the second law. Now the second law states that you have the incident ray, the normal at the point of incidence and the reflected ray. All these three should lie in the same plane. So this is the second law of reflection. So for reflection to take place, these two laws come into action so that reflection can take place. I hope when I explain these two laws to you all have got it clearly that for reflection, these two laws need to be satisfied. Now let us talk about a day-to-day example of reflection. Now we see ourselves every day in the mirror. Now what do you observe when you see in the mirror? You see an image of yourself, right? Now if you look at the image, how is the image? You will see that the image is the same size that we are. So you can say that the image is the same size as that of the object. But there are certain characteristics of the images formed by the plane mirror. The images formed by a plane mirror are virtual. What does it mean by a virtual image? A virtual image means the image of an object is formed far behind the mirror. The other property of this image is the image formed is erect and it is laterally inverted. Now, what do you mean by laterally inverted? So, if you look at yourself in the mirror with your palms facing in the mirror, you will see that the left hand appears to be your right hand and the right hand appears to be your left hand. So, this is called as lateral inversion. That is, your image is laterally inverted in the mirror. So, the image formed by a plane mirror is the same size as that of the object. It is laterally inverted, it is virtual and erect. So, these are the properties of the image inside a plane mirror. Now, we had a look at the image formation by a plane mirror. Now, this phenomena of reflection is not only applicable to a plane mirror, but also to spherical mirrors. Now, what are spherical mirrors? Now, the name itself, that is a spherical mirror, tells us that these mirrors are spherical in shape. Now, to understand what is exactly a spherical mirror, you can have a look at the spoons that you have in your house. You see the curved part of the spoon, you see the inner part of the spoon and see the outer part of the spoon. Now, when I talk about spherical mirrors, we have two types of spherical mirrors. First is the concave mirror and second is the convex mirror. Now, if you have a look at the diagram here, you see I've given you two images. One is of a concave mirror and the next is of a convex mirror. Now, if you see the concave mirror, you see the inner part of the concave mirror. Now, this inner part of the concave mirror is the reflecting surface of the concave mirror. That is, when light falls on this reflecting surface, it will get reflected back. So you see the blue color region which is shown here, this is the non-reflecting part of the concave mirror. That is, if light is incident on this particular surface, it will not get reflected back because it is the non-reflecting part of the concave mirror. Now, if you have a look at the convex mirror, you see the outer part is the reflecting surface. You see it is bulging outwards. So this bulge of the convex mirror is the reflecting surface of the convex mirror. And you see the interior part of the convex mirror is blue in color, which is the non-reflecting surface of the convex mirror. Now you see this can be approximated to the spoon which I discussed earlier. If you have a look at the spoon, you will see the inner part of the spoon can be approximated to a concave mirror, whereas the bulging part of the spoon can be approximated to a convex mirror. Now, if you have a look at the image that is being formed inside the bulging and the inward part of a spoon, you can try this experiment wherein you can take a spoon, try to see your image in the spoon, move it forward, see how the image is formed, move it backward and see how the image is formed. So you can do it a couple of times and observe the image that is formed inside the curved part of the spoon. Now we had a discussion on what spherical mirrors are. Now, before talking about how the images are formed by a spherical mirror, let's talk about some terms which are related to the spherical mirrors. Now you see, if you have a look at the reflecting surface of the spherical mirror, you can consider that reflecting surface is a part of a sphere. Now you have a sphere, obviously you will have the center of the sphere. So now we have the center of the sphere, and when we talk about mirrors, we call the center of the sphere as the center of the curvature. Now if you talk about the reflecting surface, now in this diagram, you can see the reflecting surface of the mirror. Now in the reflecting surface of the mirror, consider the midpoint of the mirror, or you can say the center of the mirror. Now this center of the reflecting surface of the mirror is called the pole, which is denoted by P. And if you draw a line from the pole passing through the center of curvature, you can assume it is an imaginary line. So that line is called as the principal axis. So these are some important terms which are related to the spherical mirrors. So now you see, if you have a look at these figures, if you see the distance from the point P to the center of curvature, now this distance is called as the radius of curvature. And then what we can do is, if we divide the radius of curvature into two halves, that becomes the focal point. And the distance from the pole to the focal point is called as the focal length. Now we will discuss in details the definition of all these terms. So describing in details the terms related to the spherical mirrors, first we have the radius of curvature. Now as I told you all that the radius of curvature is the distance between the pole and the center of curvature. Now next we have is the center of curvature. Now I told you that the point C was the center of curvature. Now if we define center of curvature, it is actually the point in the center of the mirror which passes through the curve of the mirror and has the same tangent and curvature at that point. So this is the center of curvature. Then as we have already discussed, the pole, which is present at the center of the reflecting surface. Now we know the reflecting surface of a concave mirror and a convex mirror. So the entire reflecting surface of the concave mirror and convex mirror is called as the aperture of the mirror. That is, when rays of light fall on that surface, the light is reflected back. Then next, we have the principal axis. I told you all that if we join the pole and the center of curvature and draw a line, now this becomes the principal axis. Now principal axis is an imaginary line that is drawn perpendicular to the reflecting surface. Now next we have the focal point, or you can say the focal length. Now if we talk about focal point, now this is the point where rays after reflection converge, intersect or meet at a point. So that point is called as the focal point. And the distance between the focal point and the pole is the focal length. So these are the terms which are very important related to spherical mirrors. You should know clearly the definition of all these points, since they are very important when we draw a ray diagram using a concave mirror and a convex mirror. Since now we have understood all the terms related to a spherical mirror, now let's see how images are formed by spherical mirrors. Now talking about a spherical mirror, You should know certain rules, how light passes and through what point the light will pass after it is reflected from the reflecting surface. Now, there are certain rules which we should know when we are understanding the image formation by spherical mirrors. So, the first rule states that when a ray of light parallel to the principal axis, it strikes the reflecting surface and is reflected back, it passes through the focal point. Now you can see here we have a concave mirror and we have a convex mirror. In the concave mirror, you can see that when light is parallel to the principal axis, it strikes the reflecting surface and then passes through the focal point. Now, if you have a look at the convex mirror, you see that the light rays parallel to the principal axis hits the reflecting surface and diverges away. So when it diverges away, if you extend that line, the reflected ray, you see that the light ray appears to come from the focal point. So the first point is, if the ray of light is passing parallel to the principal axis, it will pass from the focal point. Now talking about the second law that needs to be satisfied, or second rule you can say that should be satisfied when reflection takes place in spherical mirrors. Now, if the ray is passing through the focal point, say an object is kept at some distance and the ray of light is passing through the focal point as shown in the figure. You see, when the ray is passing through the focal point, it will strike the reflecting surface. Once it strikes the reflecting surface, it will get reflected back. And you see here that the refracted ray is parallel to the principal axis. So you see, if the ray of light is passing through the focal point, it will move parallel to the principal axis. Now, let's talk about the third rule. Now, if a ray of light is passing through the center of curvature, that is point C in the diagram, you can see it clearly. If it is passing through the center of curvature, it will strike the reflecting surface at a point, and then you see the ray is traveling back the same direction. So you see why it is traveling along the straight line? Because it is a perpendicular to the reflecting surface. So you see the incident ray is coming with an angle of 90 degrees and the reflected ray is also traveling through the same path at an angle of 90 degrees. So you see here that when a ray of light passes through the center of curvature, it will strike the reflecting surface and then move along the same path. This is the third rule. Now let's talk about the fourth rule. Now what does the fourth rule say? That if a ray of light is incident obliquely on the pole or at the pole, you can see in this diagram that if a ray is incident at the pole, now we know that the principal axis is perpendicular to the reflecting surface, which is making an angle of 90 degrees with the reflecting surface. So you have a ray, that is the incident ray along the pole, which strikes at the pole, and you see when it strikes the pole, it is reflected back. So you can clearly see here the phenomenon of reflection, where the angle of incidence you have I and the angle of reflection you have R. So where I is equal to R. So this is the fourth rule, which tells us that if a ray of light is incident at the pole, it will get reflected back. So these are the four rules of reflection that we should know when we actually start learning about ray diagrams. That is, when we are told to draw a ray diagram with respect to a concave mirror, or a convex mirror, we should keep these rules in mind so that we can obtain the image formation in these two mirrors. Now let's talk about the image formation by spherical mirrors. Now we know that we have two mirrors. We have the concave mirror, we have the convex mirror. Now let's do a simple activity. If we have a concave mirror, okay, and take a concave mirror and a piece of paper, focus the mirror in such a way that the reflecting part of the mirror is where the rays of the sunlight can fall. Now when this rays falls on the reflecting part of the concave mirror, place the paper in such a position that the rays are reflected on the paper. Now adjust the paper in such a way that you can see a bright spot of the sun. Now this bright spot is actually the image of the sun that is formed on the paper. Now hold the paper in that position for a few minutes. What will you observe? You will observe that after some time, the paper will catch fire. Now why is that so? Why will the paper catch fire? Now what we are doing here, with the help of a concave mirror, we are converging all the rays at one point. And due to the concentration of the light of sunlight at one point, it makes the paper ignite or it burns the paper. So that point wherein we have obtained a bright spot of the sun is the focal point of the mirror. And the distance between the paper and the mirror gives us the focal length of the mirror. Now, we know that concave mirrors is a converging mirror. Now, why is it a converging mirror? Because whenever a ray of light is incident on the reflecting surface, the reflected rays tend to meet at a point, that is converge at a point. And since they converge at a point, it is called as a converging mirror. Now, when you have an object placed at a particular distance in front of the mirror, you will have a formation of image. Now, the nature of the image that is formed depends on various factors. That is the position of the object. If we place the object beyond the center of curvature, we will get a different image. If we place the object at the center of curvature, we will get a different image. Or if we place the object at the focal point, we will get a different image. Images formed by a concave mirror can be virtual at some positions as well as it can be real for some positions. So this is how the images are formed by a concave mirror. And we are going to study this image formations with the help of a ray diagram. Now let's talk about the image formation by a concave mirror when the object is placed at infinity. Now in this figure, you can see that an object is placed at an infinite distance, that is very far from the mirror. Now when the object is placed at infinity, the rays of light will move parallel to the principal axis. Now you see here that the rays of light move parallel to the principal axis. It strikes the mirror at the point and it is getting reflected back. So when it is getting reflected back, you can see that the rays are meeting at the focal point. Now, the nature of the image that is formed here. Now you see the object is at infinite, the size of the object is greater. Whereas you see all the reflected rays are meeting at the focal point, which shows you that the size of the image that you have obtained here is very small. So in this type of ray formation or in this type of ray diagram, you get an image which is very small as compared to the size of the object. So this is the first ray diagram of a concave mirror that we study here, and you should know that whenever the object is placed at infinity, the rays meet at the focal point and the image is formed at the focal point. Now let's have a look at the second ray diagram. Now in the second ray diagram, you can see that the object is placed beyond the center of curvature. Now you see the center of curvature we have here, and an object is placed after the center of curvature. Now you see light rays are passing parallel to the principal axis, which strikes the reflecting surface, and when they strike the reflecting surface, you see here one ray is passing through the principal focus and the other ray is passing through the center of curvature. Alright, so you see one ray is passing through the principal focus and the other is passing through the center of curvature. See the point at where both the rays meet each other. You see the point where they meet each other is the point where the image will be formed. Now if you look carefully at the formation of image in this diagram, you will see that the size of the image is very small as compared to the size of the object. So here you know the nature of the object, in which it tells you that the image size is small as compared to the size of the object. So you know that when an object is placed beyond the center of curvature, the ray of light passes through the focal point also and the center of curvature, and they meet at a point where the image will be formed. So this is about the second ray diagram. In the third ray diagram, we have the image which is kept at the center of curvature. Now you can see in this figure, when the object is kept at the center of curvature, ray of light passes parallel to the principal axis. Now you see when the rays are parallel to the principal axis, it strikes the reflecting surface. And when it strikes, the reflected ray passes through the focus, and from here also the ray passes through the focal point. And when it passes through the focal point, it strikes the reflecting surface and then it is reflected back. So you see when it is reflected back, if you try to meet the reflected rays, the reflected rays meet at a point just below the center of curvature. You can clearly see in this diagram that you have the rays meeting just below the center of curvature, and if you draw a line here, it gives you the formation of image when the two rays meet at a point. So you can see clearly now that the object size and the image size. Try to compare both. You will see clearly that the size of the object here is same as the size of the image, or the image size is same as that of the object. Now if you talk about the nature of image formed in this, it is a real image formed and the image is same size as that of the object. Now let's discuss about the fourth ray diagram. Now in the fourth diagram, you can see that an object is placed between the focal point and the center of curvature. Now when the object is placed here, you see the rays are parallel to the principal axis, strike the reflecting point and pass through the focal point. Now if you look at the object height, if you look at the point A, rays from that strike the reflecting surface, it then gets reflected back through the same path and then passes through the center of curvature. If you try to extend these 2 points or 2 lines, reflected rays, you see that they meet at a point. And the point of intersection gives the formation of the image. Now in this ray diagram, you can see that the image formed is slightly bigger than the size of the object. You see here that the image is slightly greater. The size of the image is slightly greater than the size of the object. So for different ray diagrams, you have come to know that the image formation is different. That is, when we place an object at infinity, the image is formed at the focal point. If it is placed beyond C, the image is formed somewhere between F and C. So these are different terms or different ray diagrams that we have studied in terms of a concave mirror. Now let's have a look at the fifth ray diagram. Now in this ray diagram, the image is placed at the focal point. You can see it in the figure that the image is placed at the focal point. Rays of light will pass parallel to the principal axis. They will strike the reflecting surface, pass through the focal point. Now if you talk about the second ray will strike the reflecting surface, go through the same path and then pass through the center of curvature. Now if you have a look and try to intersect these two reflected rays, you will see that these two reflected rays are parallel to each other. That means at any point they won't meet each other. There will be no intersection of these points. And since there will be no intersection of this point, the image formed here will be at infinity. So we will get a real image, but this image will be formed at infinity. So this is about the ray diagram when the object is placed at the focal point. Now next is, if the object is placed between the pole and the focal point. Now you see here an object is placed at the pole. The light will pass through the object, hit the reflecting surface, and then you see it is striking the pole. Okay, the incident ray from the object is striking the pole, and you see when it strikes the pole, it is getting reflected back. So you see here the angle of incidence here is equal to the angle of reflection, as well as you can see that a ray of light strikes the reflecting surface from the top of the object and passes through the center of curvature. Now, if we extend this line behind the mirror, you see these lines will meet at a point behind the mirror and an image will be formed behind the mirror. So we know that an image which is formed behind the mirror is called a virtual image. So in this type of ray diagram, you get a virtual and erect image. And the size of the image that is formed in this type of ray diagram is slightly greater than the size of the object. Now we will see image formation by a convex mirror. Now we already learned what is a convex mirror. Now convex mirror is a mirror in which the reflecting surface of the mirror bulges outward. Now you see, if a ray of light is incident on a convex mirror, it is going to get reflected back. And when it is getting reflected back, it appears to be diverging, or the reflected rays appears to be diverging. So since the reflected rays are diverging, it is also called as a diverging mirror. And this mirrors, it is also called a diverging mirror. Now if you extend the reflected rays behind the mirror, the image is formed behind the mirror in case of a convex mirror. Now in convex mirror, the image formed is always virtual and erect, no matter whatever the position of the object is. That is, the image formed by a convex mirror is always virtual and erect, no matter wherever the object is placed. If the object is placed beyond C, the image will be formed behind the mirror. If it is placed at infinity, the image will still be formed behind the mirror. Now let's discuss the formation of ray diagrams by a convex mirror. Now in this figure, you can see we have a convex mirror bulging outwards, and imagine an object is placed at infinity. So ray of light will pass parallel through the principal axis. Then it will reflect at the reflecting surface. So you see the rays, the reflecting rays appear to diverge. And if I extend this rays and meet at a point, you see that they meet at the focal point. So you can see here that the image that is formed is behind the convex mirror. And if you look at the size of the image that is formed, you see the image is very small. That is, the size of the image is very small as compared to the size of the object. So you see, a convex mirror forms a virtual image and an image which is very small in size when an object is placed at infinity. Now in the next ray diagram, we see that if an object is placed close to the mirror, you see the light rays pass parallel to the principal axis, they strike the reflecting surface, and when they strike the reflecting surface, they diverge from the reflecting surface. If we extend those lines, they meet at a point behind the convex mirror. And if you see the point of intersection, that is the point where the image is formed. Now you see in this case that the image formed here is a virtual image and the size of the image is small as compared to the size of the object. So you see, we have learned here the image formation by convex mirrors. And we saw here that the two ray diagrams that we discussed, in this, the image is a virtual image. That is, image is formed behind the convex mirrors. But if you have a look into the concave mirrors, the image formation in concave mirrors, you see the images were formed that is in front of the mirror, not behind the mirror. So students, let's have a quick recap of what we have learned today. We started with the laws of reflection, image formed by a plane mirror, spherical mirrors, image formation by spherical mirrors. So I hope you enjoyed this lecture on reflection, and don't forget to subscribe to our YouTube channel Empower Tutorials, and for more upcoming videos, stay tuned to our channel. Thank you.